In 2023, a Chinese chip company reported a revenue jump that most firms would quietly celebrate and move on from. The number was just over 30%. Not extraordinary in isolation. Semiconductor cycles do that sometimes. Demand spikes, supply tightens, pricing shifts, revenue follows. Except this company wasn't supposed to grow at all. It had been placed on the US Entity List, cut off from advanced manufacturing tools, restricted from accessing key American technologies. The assumption, widely repeated in policy circles, was simple: starve the inputs and the output collapses. That didn't happen. Instead, revenue doubled within roughly 12 months. That gap between expectation and outcome is the actual story here. Not the growth itself, but the failure of the model that predicted decline. Because sanctions, at least in theory, operate like a choke point. You don't need to shut everything down. You just need to control the critical dependencies, the few technologies or components without which the entire system stops functioning. In semiconductors, those choke points are well known. Extreme ultraviolet lithography machines, advanced electronic design automation software, high-end GPUs, precision manufacturing equipment dominated by a small cluster of companies, many of them either American or aligned with US export controls. The logic was clean. Remove access to those and a company falls behind. Not immediately, but inevitably. So when a sanctioned firm reports accelerated growth instead of contraction, one of two things must be true. Either the sanctions weren't enforced as tightly as assumed, or the company changed its structure in a way the sanctions didn't anticipate. The first explanation is comfortable. It suggests a policy execution problem, something that can be fixed with stricter controls, more coordination, better compliance. The second is less comfortable. It implies the target adapted in a way that bypassed the original pressure points entirely. The data leans toward the second. Look at where the revenue actually came from. It wasn't cutting-edge 3-nanome or 5-nanome chips competing with the likes of leading-edge foundries. That space remains constrained. The restrictions on advanced nodes are real, and they've had an impact. Growth came from what the industry usually treats as less glamorous: mature nodes. 28-nanome, 45-nanome, even older. On paper, these are legacy technologies, not where the headlines are. Not where the geopolitical tension is supposed to concentrate, but they are everywhere. Automotive systems, industrial machinery, power management, consumer electronics that don't need bleeding-edge performance but require reliability at scale. And more importantly, they are harder to sanction effectively because the ecosystem is broader, the equipment is more widely distributed, the knowledge base is less concentrated. You're not dealing with a handful of irreplaceable machines anymore. You're dealing with a global manufacturing layer that has redundancy built into it. So the company didn't try to break through the ceiling it couldn't reach. It lowered the ceiling and expanded horizontally. Instead of competing at the frontier, it absorbed demand in the layers beneath it. That shift matters more than it looks, because sanctions are calibrated around denial, preventing access to something specific. But they're less effective against substitution, when the target simply moves into a different part of the value chain where the constraints are weaker. There's also a timing element most commentary misses. When restrictions were imposed, global semiconductor supply chains were already under stress. The aftershocks of pandemic-era disruptions hadn't fully settled. Lead times were still extended in several categories, especially for automotive and industrial chips. That created a vacuum, and vacuums don't stay empty. Domestic buyers, particularly in China, began shifting procurement toward local suppliers, not necessarily because they were superior, but because they were available and politically safer. A sanctioned company, ironically, becomes a more reliable partner in that context. It's already cut off. There's no additional downside risk. Orders consolidate, revenue follows. This isn't about technological parity. It's about market positioning under constraint. And once that positioning shifts, it doesn't easily reverse. There's a counter-argument worth addressing. Some analysts will say this growth is artificial, driven by state subsidies, policy support, or short-term stockpiling. That it reflects political prioritization rather than genuine competitiveness. There's truth in that. Chinese industrial policy has clearly played a role. Access to financing, preferential procurement, and direct government support all contribute to stabilizing and expanding these firms. But that doesn't negate the structural shift. It accelerates it. Subsidies can't create demand out of nothing. They can redirect it. And once supply chains adjust, once manufacturers qualify a new supplier, integrate it into production, align logistics around it, switching back isn't frictionless. Even if sanctions were lifted tomorrow, the market wouldn't snap back to its previous configuration. That's the part that complicates the original assumption, because the goal of sanctions isn't just to slow a company down in the short term. It's to shape long-term technological trajectories, to preserve an advantage at the high end. But in doing so, there's a secondary effect. You push the target to consolidate the layers you don't control as tightly. And those layers, while less visible, are economically dense. They generate cash flow. They build manufacturing experience. They create supplier networks. They train engineers at scale. Which raises a quieter question. If a company can't reach the frontier, but becomes dominant in everything below it, what exactly have you contained? Or have you just moved the center of gravity somewhere else? There's a detail buried in procurement data that most coverage skips over because it doesn't sound dramatic. Wafer starts. Not at the cutting edge, those are still constrained, but across mature nodes, the number of wafers being processed began climbing at a pace that didn't match the crippled by sanctions narrative. Quietly, steadily, almost boringly consistent. That's where the story moves from theory to mechanism. Because revenue doubling doesn't happen from slogans or policy speeches. It happens when orders turn into shipments, shipments into invoices, and invoices into repeat contracts. Something in that chain held, and not just held, but scaled. Start with equipment. The assumption behind export controls was that without access to the most advanced lithography systems, progress would stall across the board. That's only partially true. The most advanced nodes depend on extremely concentrated technology, a handful of companies, very specific machines. Mature nodes don't. They rely on older generation deep ultraviolet systems, deposition tools, etching equipment, much of which exists in secondary markets, legacy supply chains, or non-US ecosystems. It's not cutting edge, but it's sufficient. And more importantly, it's obtainable. Not always directly, sometimes through intermediaries, sometimes through subsidiaries that weren't initially covered, sometimes through equipment already installed before restrictions tightened. None of this is particularly mysterious. It's just fragmented. Sanctions work best against centralized dependencies. They're less precise when the dependency network is diffuse. Then there's design. Electronic design automation software is another choke point, heavily dominated by US firms. Restrictions here matter, but again, the impact varies by node. Designing a 5-nanometer chip is a different problem than designing a 40-nanometer power management IC. Lower complexity opens the door to alternatives. Domestic software, open-source tools, older licensed versions, none of them ideal but collectively workable. The result isn't elegance, it's redundancy. And redundancy is underrated in discussions about technological competition. It doesn't win headlines, but it builds resilience. Now layer in demand. China doesn't need to export every chip it produces. Its domestic market is large enough to absorb enormous volumes, especially in sectors that don't require bleeding-edge performance. Electric vehicles, industrial automation, telecommunications infrastructure. All of these consume vast quantities of semiconductors that sit comfortably within mature node capabilities. When foreign suppliers become politically or logistically uncertain, local alternatives gain an edge that has nothing to do with technical superiority. It's about predictability. A domestic manufacturer under sanctions isn't suddenly going to face new geopolitical risks. It's already operating under maximum restriction. From a buyer's perspective, that stability becomes valuable. So procurement shifts. Not completely, not overnight, but enough to change revenue trajectories. There's a historical echo here that's worth noticing. In the 1980s, the United States pressured Japan over semiconductor trade imbalances. The response wasn't immediate collapse. It was adjustment. Shifts in production focus, government coordination, strategic investment. Different context, different scale, but a similar pattern. External pressure compresses one part of the system and expands another. The company we're talking about didn't invent a new physics of chip making. It reorganized around constraints, and that reorganization had a few specific characteristics. First, vertical integration increased. When external suppliers become unreliable or restricted, internalizing more of the value chain reduces exposure. It's not always efficient, but it's controllable. Second, product portfolios shifted toward high-volume, lower-margin segments that collectively generate substantial cash flow. Instead of chasing the highest performance chips, the focus moves to ubiquity, being present in as many devices as possible. Third, relationships with domestic customers deepened. Not just transactional supply, but co-development, long-term contracts, sometimes even shared investment. These are slow changes. They don't show up immediately after sanctions are announced, but once they start compounding, they become difficult to unwind. There's also an uncomfortable feedback loop. As revenue grows, even within constrained segments, the company gains more resources to invest. Not necessarily to leap directly to the most advanced nodes, that gap remains significant, but to improve yield, expand capacity, refine processes, incremental progress. And over time, incremental progress accumulates. This is where the initial expectation, that cutting off advanced inputs would freeze development, runs into reality. Development doesn't stop, it diverts. Instead of a straight line toward the frontier, you get a widening base. Think of it less like a ladder and more like a plateau expanding outward. From a policy perspective, this creates a dilemma. If the objective is to prevent access to the highest-end technology, the current approach has some effect. There are clear bottlenecks that remain intact. But if the objective is to limit overall semiconductor capability, production volume, supply chain influence, industrial depth, the outcome looks different. Because volume matters. Control over large portions of the unremarkable chip market translates into leverage. Pricing power in certain segments. Influence over downstream industries that depend on consistent supply. And those industries aren't trivial. Automotive manufacturing can stall over relatively simple chips. Industrial systems can't function without them. Even parts of telecommunications infrastructure rely on components far removed from the cutting edge. So while attention stays fixed on nanometers and transistor density, a parallel shift happens in the background. Capacity accumulates where scrutiny is lower. It's tempting to treat this as a temporary distortion, something driven by current geopolitical tensions that will normalize over time. Maybe, but normalization assumes reversibility, and that's not guaranteed. Once a domestic ecosystem reaches a certain scale, it develops its own momentum. Suppliers, talent pipelines, capital flows, they start reinforcing each other. Even if external restrictions ease, the incentive to revert fully to previous dependencies weakens. There's one more layer to consider, and it's less tangible. Perception. Within China, sanctions are often framed not just as economic measures, but as signals of vulnerability, evidence that reliance on external technology can be weaponized. That perception shapes corporate and state behavior in ways that aren't captured by quarterly reports. Investment decisions become more defensive. Redundancy becomes a priority, even at the cost of efficiency. Independence, once an abstract goal, turns into an operational mandate. Which brings us back to that revenue figure. It's easy to read it as a success story, a sanctioned company outperforming expectations. It's more accurate to read it as a system adjusting under pressure. And the adjustment isn't symmetrical. It strengthens some parts while leaving others constrained. The question is whether those strengthened parts end up mattering more than originally assumed. There's a temptation to treat this as a quiet success story for China's semiconductor push. A sanctioned company absorbs pressure, finds a workaround, and comes out stronger on the other side. That's too clean. Because if you zoom in, The limitations are still very real, and they're not cosmetic. Start with advanced nodes. The gap there hasn't closed in any meaningful sense. Producing chips below 10 nanometers at scale, with competitive yields, still depends on a stack of technologies that remains tightly controlled. Lithography is the obvious one, but it's not just lithography. It's metrology systems, advanced materials, software ecosystems that have been refined over decades. Those constraints don't disappear because revenue at 28 nanometers is strong. They sit there, quietly, setting a ceiling. And ceilings matter when the global industry keeps moving. High-performance computing, AI training, cutting-edge smartphones, these segments don't wait. They pull the frontier forward, and if you're not in that race, you're not shaping its direction. So yes, the company adapted. But it adapted downward, not upward. That distinction is easy to miss if you focus only on growth rates. There's also a quality question. Not every 28 nanometer chip is interchangeable. Yield rates, the percentage of functional chips per wafer, determine whether production is actually efficient. Lower yields mean higher costs, even if nominal capacity looks impressive. Data here is patchy, and I'm not entirely certain where the exact numbers land. But industry estimates suggest that yields at certain Chinese fabs lag behind global leaders, especially in more complex designs. That doesn't stop production. It changes the economics. Higher defect rates can be absorbed if there's enough demand and enough policy support. Over time, yields improve. But the path isn't frictionless, and it eats into margins. Then there's the question of equipment sustainability. Accessing older generation tools is one thing. Maintaining them, upgrading them, replacing parts, that's another. Supply chains for spare components can become a bottleneck in themselves, especially if original manufacturers are restricted from providing support. This creates a kind of technical drag. Nothing breaks all at once. Instead, efficiency degrades in small increments. Downtime increases, calibration becomes harder. You compensate, but each compensation adds complexity. It's manageable. It's not ideal. Now, step back and look at the broader system. The United States isn't targeting mature nodes with the same intensity for a reason. The strategic concern centers on technologies that enable military capabilities, advanced computing, and long-term technological leadership. From that perspective, allowing expansion in lower-end segments might even be seen as acceptable collateral, or, in some interpretations, a pressure valve that prevents more aggressive escalation. But that assumes the layers are cleanly separable. They're not. Revenue from mature nodes doesn't stay neatly contained. It funds research, subsidizes experimentation, supports talent retention. Engineers don't specialize in isolation forever. Skills transfer. Process improvements at older nodes can inform approaches at newer ones, even if indirectly. More importantly, scale builds confidence. An industry that proves it can meet domestic demand in one segment becomes more willing to push into adjacent ones. The psychological barrier lowers. There's a second counter-argument that deserves attention. Some analysts argue that what we're seeing is front-loaded demand, companies stockpiling chips out of fear of future restrictions. If that's true, revenue spikes could normalize once inventories stabilize. It's a reasonable point. Inventory cycles in semiconductors can distort short-term data significantly. A surge in orders today doesn't always translate into sustained demand tomorrow. But even if part of the growth is front-loaded, the structural changes we discussed earlier don't disappear when inventory levels adjust. Supplier relationships have already shifted. Production capacity has already expanded. Domestic alternatives have already been qualified and integrated. Those changes persist. What might fade is the pace, not the direction. There's also a geopolitical layer that complicates any straightforward assessment. Sanctions are not static. They evolve. Lists expand, rules tighten, loopholes close. The initial round of restrictions is rarely the final one. So the environment this company adapted to last year may not be the same environment it faces next year. That introduces uncertainty into any prediction. Will additional controls target mature nodes more aggressively? Possibly. There's been discussion in policy circles about tightening restrictions on equipment used even in older processes, precisely because of the kind of growth we're seeing. But that path has trade-offs. Expanding controls too broadly risks disrupting global supply chains, not just Chinese ones. Mature node chips are deeply embedded in international manufacturing networks. Restricting them aggressively could create shortages that affect companies far beyond the intended target. And that brings us to a subtle but important tension. Sanctions aim to constrain a competitor without inflicting unacceptable costs on the global system, or on the sanctioning country itself. That balance becomes harder to maintain as the target adapts. Each adjustment on one side forces a recalibration on the other, which means the current outcome, revenue growth under constraint, isn't a final state. It's a phase in an ongoing interaction, one move, then another. The mistake would be to freeze the analysis here and declare either success or failure. It's neither. It's a system in motion, with feedback loops that are still playing out, and the direction of those loops depends on decisions that haven't been made yet. If you strip away the headlines and just look at the mechanics, what happened here isn't a loophole story. It's a reconfiguration. A company was cut off from the top layer of a highly concentrated industry. Instead of forcing its way back in, it expanded everywhere else it could reach, and those areas turned out to be larger, more stable, and less exposed than many people assumed. That doesn't make sanctions irrelevant. It means they worked, just not in a linear way. They did slow progress at the frontier. That part is real. The gap at advanced nodes remains, and it matters for AI, defense systems, and the next generation of computing. But at the same time, they accelerated something else. They forced consolidation in the middle and lower layers of the semiconductor stack. And those layers, taken together, are not marginal. They're the foundation on which most of the physical economy runs. Cars don't move without them. Factories don't operate. Power systems don't regulate themselves. So the outcome is uneven. High-end capability is constrained. Broad-based industrial capacity is reinforced. You can argue that this is acceptable, even desirable, if your objective is to preserve leadership in the most critical technologies. There's a logic to that. Control the frontier, and you control the direction of innovation. But that argument quietly assumes that control at the top translates into leverage over the entire system. I'm not convinced that holds as cleanly as it used to, because influence doesn't only come from being the most advanced supplier. It also comes from being the most reliable one across large segments of the market, from being the default option when alternatives are uncertain or politically risky. And reliability scales. Once a company becomes embedded in thousands of supply chains, not at the cutting edge but everywhere else, it becomes difficult to displace, even if better technology exists elsewhere. Switching suppliers isn't just a technical decision. It's a logistical one, a financial one, sometimes even a political one. That stickiness is where the long-term implications sit. There's another angle that doesn't get enough attention. Sanctions send a signal beyond the immediate target. They tell every other country, every other company operating in the same ecosystem, that access to certain technologies can be restricted abruptly, that dependencies can turn into vulnerabilities. Different actors interpret that signal differently. Allies might double down on alignment, accepting the trade-offs for security guarantees. Others might start hedging, diversifying suppliers, investing in local capabilities, even if those capabilities are less efficient. That's how fragmentation begins. Not as a dramatic break, but as a series of small, rational decisions that gradually reduce interdependence. And once that process crosses a certain threshold, reversing it is difficult. The semiconductor industry has been one of the most globally integrated sectors for decades. Design in one country, fabrication in another, equipment from a third, materials from a fourth. Sanctions introduce friction into that model, sometimes necessary, sometimes strategic, but always consequential. Now, bring it back to that revenue figure. A doubling in 12 months under restriction doesn't mean the company has won. That's too simplistic. It doesn't mean the US approach has failed either. It means the interaction between pressure and adaptation produced a result that sits somewhere in between, which is usually where reality ends up. My read is this. The current strategy is buying time at the top of the stack, but it's also compressing the rest of the stack into more self-sufficient regional systems. That trade-off might be intentional. It might be an unintended side effect. It's probably a bit of both. The open question is how far that compression goes. If mature node capacity continues to expand domestically, if supply chains continue to reorient, if the supporting ecosystem, materials, equipment maintenance, design tools, keeps filling in gaps, then the center of gravity in semiconductors shifts, not upward toward the most advanced nodes, outward across a wider base. And that kind of shift is harder to counter because it doesn't rely on a single choke point you can tighten. It's diffuse. My opinion, for what it's worth, is that policymakers underestimated how much economic weight sits outside the frontier. There was an implicit belief that controlling the most advanced technology would cascade downward in terms of influence. What we're seeing suggests the cascade doesn't fully transmit. It leaks. Here's the doubt I can't fully resolve. At what point does incremental improvement at lower nodes begin to meaningfully close the gap with higher ones for certain applications? Not in absolute performance terms, but in good enough thresholds that reshape demand. Because if that threshold is lower than assumed, then the importance of being at the absolute frontier narrows. And if it's higher, then the current strategy holds more firmly than critics suggest. That's not a question with a clean answer yet. Prediction? The next phase won't be about whether sanctioned companies can survive. That part is already settled. It will be about whether restrictions expand downward, into the mature node ecosystem, and whether the global system can absorb the shock if they do. If controls tighten further, expect short-term disruptions far beyond China. Supply chains will feel it. Prices will reflect it. If they don't, expect a quieter outcome. A world where the cutting edge remains concentrated in a few places, while the bulk of production, the part that actually touches most industries, becomes more regionally anchored and less dependent on any single external actor. That's not a dramatic break, it's a slow realignment, and those are usually the ones that last. If you've made it this far, you already know this isn't a simple story. Keep watching the parts of the market that don't make headlines. They tend to be the ones that move first.